What's up? What's up? Now, I said I was promising that I was going to show you guys the shorter version of graphing rational equations. An example I was going to do was this here. Let's take a look. And this is going to say f of x is equal to x minus 4 over x squared minus 16. Now, one of the things I realized is that the denominator is the difference of two squares. So really I have x minus 4 over x minus 4, x plus 4. Now, it's very tempting for us to go ahead and start canceling this out, but let's not do that yet, okay? So I cut it down into where we're going to skip doing symmetry just because it's not likely that it's going to have those symmetries. So we're going to go dive directly into finding the X Intercept. So here we go. So we're going to first find the X Intercept. So what do we know about the X Intercept? What we know is that the Y is equal to 0. Okay, so the only way a fraction is equal to 0 is if the numerator is equal to 0, right? So what I know is that 0 divided by x squared minus 16 is going to give me 0. So only the numerator matters, all right? So what I'm going to do is go ahead and set 0 equal to the x minus 4, which is the numerator or the top, right? So what I have here is that x is equal to 4. But here's the problem. I got x equals 4, but look at what this is telling me. I have restrictions here, right? And these restrictions tells me that x cannot be negative 4 or positive 4. And since I got a positive 4 here, I have to go ahead and reject this because I can't have x equaling 4 because it would make my denominator 0. And if I have a 0 in the denominator, it's no good. So what do I have here? I have that the x-intercept, there is none. Okay? Next thing is that I have to go ahead and find the y-intercept. What do I know about the y-intercept? I know that the y-intercept is that the x is equal to 0. So I can go ahead and plug it in. So I have, let me see here, 0 minus 4 divided by 0 squared minus 16. Well, that's going to equal to negative 4 over negative 16, which is equal to 1/4. So what I have here is that this is going to be 0 and 1/4. Okay, so that's done. Next thing is that I'm going to go ahead and look for the horizontal asymptote. So what I'm comparing is the highest, well, I should say the term with the highest power on top versus the term with the highest power on the bottom. If I look at this, on top I have an x squared, and on the on the top I only have an x. The bottom I have an x squared. So since the top power is less than the bottom power, that means I have a horizontal asymptote at y equals 0. Okay. So there we go. So that'll be good to know. All right. And then last but not least, we're going to go ahead and look for a vertical asymptote. All right? For the vertical asymptote, that is going to be based on the restrictions. Okay, so essentially, this so-called factored form is what's important. So let me do this here, duplicate this, bring this down, and let's go ahead and from here, based on restrictions, what I have to do is take this denominator and set it equal to 0 or not equal to 0. So I got x minus 4 can't equal to 0. X plus, or you know what, let's just leave it as equal to 0. And x plus 4 is equal to 0. Okay, so that means I have an x equals to 4 and x equals negative 4. But what you notice is this. Check this out. What you notice is that x minus 4 would cancel out, right? And since they cancel out, that means that x equals 4 is not going to be a vertical asymptote. However, this is going to be a hole. While this right here, since this does not cancel out, right? Since it does not cancel out, actually, maybe I should do it this way. Yeah, this is fine. Since this does not cancel out, that means this, I'll have a vertical asymptote at x equals negative 4. So from here, what I want to do is I want to plot points around my vertical asymptote. So let's go ahead and make a table. In fact, let's bring this down a little bit. Okay, oops. What I know is that this is my x, and my f of x is equal to x minus 4 over, come on, I can either use the x squared minus 16, or I can use the x minus 4x plus 4. All right, so I know that my vertical asymptote is at negative 4. So I want to know what's happening to the left of it and also to the right of it. Okay, so to the left of it is going to be negative 5, negative 6. To the right is going to be negative 3 and negative 2. All right, so here I'm going to have, so negative 6 will be negative 6 minus 4 over negative 6 squared minus 16. And that's going to be a negative 10 over, that's going to be 36. So is that 20? So it'll be negative 1/2. And let's double check this. It's going to go with test mode. Oopsies. What's that number there? It was negative 6. Yep, negative 0.5, so that's correct. Okay, and then what we can do is go back and change these to negative 5. And we get negative 1. And negative 4 is where the vertical asymptote is. And at negative 3, oopsies. That gives me 1. And let's take a look at negative 2. gives you 0.5. Okay, so with that in mind, I'm going to go ahead and plot this. There we go. All right, so we have no x-intercept. The y-intercept is at 0, 1/4. All right, we have a horizontal asymptote at y equals 0, which is this horizontal line right here. And to make it look a little bit thicker here and dotted so that we can see it. And I have a vertical asymptote at x equals -4. Let's go ahead and make that also a little thicker and dotted. All right, so there we go. So let's go ahead and plot this. So at -6, we have -1/2. At -5, we have -1. And then on the other side, at -3, we have +1. And -2, we have +1/2. Okay? So if you notice what happens. So what this is showing us is that this side here to the right of this vertical asymptote is that what we're going to have is something like this. That's going to go up this way and this way. And then over here on the left side of this is going to do something like this and like that. Okay, so when I plot those points, it's more about how does it curve. All right, and since there's a hole here at 4, so at 1, 2, so if I didn't do this part right here, what I know is that, well, let me see, 1, 2, 3, 4, there would be a hole. So essentially what would happen is that as this was to blow up, once it really scan into this, so this will just kind of go right into that direction there. Now, how do I know the location of that hole? Well, here's the thing. If I was to reduce this right here, right, where the x minus 4 cancels out, what I'll have left is that f of x is equal to 1 over x plus 4, right? So if I was to find where, f of 4 would be, well, that's going to be 1 over 4 plus 4, which is 1/8. All right, so 1/8 would make sense. That would be right about there. So that's how I could find, where this position is of that point, of that circle or that hole. Okay, Doug? Well, hopefully that answers your question. If you have any questions, let me know. Talk to you later. See ya.